Hello everyone, welcome to a video going over this quiz that we're going to be having on Thursday or Friday depending on which class you're in. It's our first quiz going over that logarithms material. This first question doesn't actually have any logarithms or exponents, it's just about inverses. I want to make sure that we understand inverses before we start because logarithms and exponentials are inverses of each other. So finding the inverse of each function, there are a lot of ways to do this question. I'm going to show you two of them, my two favorite ways. You can always pick your favorite method. So the first thing you want to do to find the inverse is to rewrite f of x as y. After you've done that, you want to switch the positions of x and y. Then you need to multiply everything by that 5, or you could subtract 2 over. It doesn't really matter which one you do. Most students prefer to subtract the 2 over first, so I'm going to go ahead and subtract the 2 over first. Now we want to get rid of that fraction. There are multiple ways to do this. You could either multiply everything by negative 5 over 2. I actually prefer to multiply everything by 5 first and then divide by negative 2 after that. People tend to make fewer mistakes when you do that, so you want to multiply everything by 5. So by multiplying everything by 5, you get 5x minus 10. Those are both just multiplied by 5, and the right-hand side, the 5s are going to go ahead and cancel out. Then, solving for y, we want to divide everything by negative 2. But writing your final answer, you don't want to write equals y. You want to write using the correct notation. The correct notation, you're going to write on the left-hand side, and you're going to write f with a little negative 1 of x. That says f inverse of x. That is the undoing. It is the backwards of x. Please note, you could have also ended up writing your answer differently, depending on which work you followed. And if you did that differently, you might have ended up at 5 over 2 negative plus 5 like this. These are equivalent to each other, because you could just divide them both by negative 2. Both would get you full credit. That's method 1 to doing this question. Method 2 to doing this question is asking yourself instead, what is happening to x, and how would I go about going backwards with it? So in this question, the very first thing that's happening to x is, if I plugged in like 10 for instance, and you would get multiplied by 2 over 5, negative. So you'd be multiplying by negative 2 over 5. And after you multiply by negative 2 over 5, you would go ahead and be adding 2. So how could I go backwards to doing this question? Well, going backwards instead would be f inverse of x is going to be equal to x minus 2. And then afterwards, we would divide by negative 2/5. But dividing by a fraction is multiplying by the reciprocal, multiplying by negative 5 over 2. And that's what I was talking about over here. If you wanted to, you could have multiplied by negative 5 over 2 right here, and it kind of would have gotten you right there to the answer. Anyways, I've given you 1, 2, 3 acceptable answers. I will give full credit for any of those 3. I do not care which one you do. They are all inverses, but you must have this correct notation, f inverse of x, to get full credit. Pick your favorite. Let's do problem number 2 now. Solve each equation without logarithms. I say without logarithms because you don't need a logarithm on this question. Technically, you're allowed to use logarithms on this one if you really want to, but we haven't learned the techniques of logarithms required to solve this. So instead, we're going to use all of our exponential rules. The exponential rules for these questions is first recognizing that all of these guys are a power of 6. Specifically in your notebooks, you should have a huge list of numbers written out that we did together. Specifically, 6 to the 1 is 6, 6 squared is 36, and 6 cubed is 216. You're going to need those for this problem because we have all these 6's in it. Let's go ahead and rewrite each one of those as a base of 6. So we're going to change that 1 over 6. We're going to change that to a 6 to the negative 1. It's still getting raised to the negative 2x minus 3. That 36 is going to get rewritten as 6 squared. And then the right-hand side there, that 216 is going to get rewritten as 6 cubed to the negative x. And this is negative 2x minus 3, the same negative 2x minus 3 that's right there. Continuing on with this question, we need to simplify, get rid of those parentheses. So we have 6 to the negative 1 to this guy. You just multiply, distribute. So that means we're going to have 6 to the 2x plus 3 multiplied by 6 squared equals 6 to the negative 3x. Let you pause, catch up for a second, think about what just happened. The next idea, though, we need to add our exponents. Remember we need to remember the rule that when you multiply like terms, you're adding these exponents together. So adding these exponents together is going to be 6 to the 2x plus 5 equals 6 to the negative 3x. After that, we finally are able to simply say, oh, both of these guys have 6 raised to a power, therefore those powers must be the same as each other. 2x plus 5 is going to be equal to negative 3x. Subtract the 2x over, get negative 5x over here. Divide both sides by negative 5. Negative 1 equals x. Not too terrible. The last two questions are total freebies. Honestly, anyone missing these, I have a feeling that we're not paying attention during class because it's just a rewriting of the definition. We want to use the idea that we have n is our base. We're raising it to the negative 4 power, and we equal 77. I don't need you to tell me what the answer to that problem is. I don't need you to try to solve that problem. I literally just want you to rewrite it. That's it. Prove to me that you understand this definition. Some students have been using a little trick that I showed in 2 of my classes, so if I didn't show it in your class, here's a chance for you to see it. Just writing the same problem again. You can always simply take this number here and raise it to this power, and the result will be this guy. This is called a logarithm loop. It works in both directions. What am I saying that it works in both directions? Well, I'm saying it's n to the negative 4 is 77, so I'm saying n to the negative 4 is 77 in this problem, but it works the other way around too, because if I'm in exponential form and I start with the base, that n, the log of n of 77 gives us negative 4. That is to say, I could write log n of 77 and get negative 4. This little guy can really help students who are struggling with this definition. Going back, number 4, same concept. We're going to write log base 15 of x equals y. A logarithm is an exponent. Anyways, might be a good idea to jot these problems down in a notebook, something like that. Good luck coming up on this quiz on Thursday or Friday.